your second step is going to be. Okay, the problem is counts right at this here. Because there's two numbers here, you can't do a log of it yet. So the first thing I do before that, I'm going to divide by 6.489 first. Yeah. Right, because you can only have one thing on the left and one thing on the right. Can someone please do 500 over 6.489? Actually, maybe Madison is going to be that person since you're next in line. It's like 80 something, maybe. Now, when you're doing that, please leave that number in your calculator. Okay, because if you take a look, like I'm assuming there's 1,000 decimal places after that, right? So be as exact as possible. All right, Albert, what do you do next, please?
You do log of
Yeah.
77.5.
I'm going to not show that because people will get at me for skipping steps. But that is correct, okay? Now the nice thing is this number you have in your calculator, most calculators should just be able to hit log, right, and then divide by 1.580 and log. And so what does that equal then, please?
I got
9.49. Is that right? Not that I don't trust you, but that seems a lot higher than that. That's okay. Okay, so here comes the question. When exactly is there 500 kilowatts produced? Yes. 1989 and a half. So this will be therefore in about in late June. You don't be that accurate. Okay, where did I get late June from other than me being a math teacher? Yeah, it's like it's half, right? Like half would be like the end of June, right? Again, this is like June. This is like the last day of school. Please don't. All the way back. I know you will always take them with it, but we'll start with that on the next question. Was that so? Was it difficult? Whoever raised that question was just getting the idea of the 1980. Was that what the problem was? Because that's what the difficulty was in that question. Okay, let's get to today's lesson. Today's lesson is called compound interest. I could try talking. Have I talked to about her yet? Okay. I hope she doesn't watch this video.
She watches your videos for you? How are you viewing it?
You really think she does? I wonder what he did today at school. Yeah, I don't think she did. I'm going to hit pause because I'm not allowed to talk about her publicly, so I'm going to hit pause and tell the story. Jobs after university, you'll be able to do some of this stuff. All right. One more joke. Okay, let's go to this here. Compound interest. This is interest earned on interest. And I apologize to those that came from 3M. This is going to be the most boring lesson you've ever seen, but stay with me here. Example 1 is going to say a Wayne Gretzky hockey card. Edmonton Oilers.
What's that? Edison?
Is worth, we'll say, $200. Okay, when I was a kid, my whole dream was to save up like my baseball card collection to make a lot of money, and I would pay that off with my university bill. That was my dream, right? Like, yes. So now we're going to say if it goes up, by, we'll say, 5% each year, find its value in 5 years. I will say 8 years. Okay, we're going to do this the good old-fashioned way, which is a table. Okay. So what we're going to do is we're going to do year. I'll make a chart that says year. Calculation. And value at the end here. Okay, so if something goes up by 5% each year, how would I calculate what its value is going to be? If something increases in value by 5%. Times by 1.05, that's the difficult way to, this is how you do it, right? But the way you can do it, that's what we're going to get to. Okay, so the way he got that from was, Amanda, you're starting at 100%, you went up by 5, that's a 0.05. Okay. Can someone please get their calculators out and do 200 times 1.05? All right. It's not bad. We're doing good with our hockey card here. We're up $10 after 1 year. I'm feeling good about that. Okay, in year 2, how do we figure out our value after year 2? This is where compound interest comes in. Yes?
210 times 1.05.
Very good. Okay. So 210 times 1.05. The idea is for this is you're earning interest on the original $200 that you started with, as well as the $10, right, that you earned in the first year. What is 210 times 1.05, please?
220.5.
220 point how much?
Yeah.
0.50. 0.5. Now, here's the thing you've noticed. In the first year, we got $10. How much did we earn in the second year? $10.50. You earned a little bit more, right? But it's going up. I'm going to do one more here because I'm a mathematician. I'm not a accountant yet. Year 3 is going to be 220.50 times 1.05. Okay, I definitely can't do this in my head. Can you do 220.50 times 1.05, somebody please? 231.52. 53? Isn't there some rounding thing in science where you go to even numbers? I don't know that. Is that true here in science?
If it's a 5,
Isn't it is that 0.525 or no, it's 5 times?
You
Five,
round
two.
to the nearest number, yeah, in the smallest of the same number.
Let's just round up for right now. I'm going to round up on 5. That's not going to do it. I'm not a statistician. Okay. Now, the point is what I'm trying to say for this is, in this case, is that right? Can somebody confirm that number? That's right?
Yeah.
Okay, so in this case, we earned $10.50. In this case, we earn what? Oh, $11.03. Okay, so you're going up by about 50 cents plus a little bit each time. Now, my problem as a mathematician is I don't like tables, to be perfectly honest. I want to get right to number 8 very, very quickly. Let's use our exponent rules if we can. What's another way I could have done 210 times 1.05? Is there a better way I could have done that? You don't have to erase, okay? But is there a better way I could have done 210 times 1.05? Well, what's 210 the same as? What's 210 the same as?
200 times 1.05.
Right. So I could have called it, if I wanted to, and I'm going to, this as 200 times 1.05, and then times another 1.05. Which conveniently is 200 times 1.05 squared. So you see what I did there? Right? Try and calculate that out. Somebody please make sure that equals 220.50. Somebody please make sure that works out. Does it work? I hope it does. Good. Lovely. Okay. So this one here, what would this one be then? What would number 3 be? Not all at once? The same thing, okay? So this is going to be 200 times 1.05 cubed, right? That should be, and that should give us 231.52.5, right? Approximately? Yes? So what's the 8th year going to be then? Very good. Never said that. Right? So can somebody please do 200 times 1.05 to the 8th? Go ahead.
295.
A little slower. 295. 49. Can somebody confirm that? Not that I don't trust them?
Yeah.
We're good? Okay, so this is where my hockey card dreams fell apart when I was 8 years old. Okay, right. After 8 years, it's only gone up $95, and that's when you invested. Okay, questions about the process here, okay? Because what we're trying to do in this course is to find a better pattern than just multiplying the same number again and again and again, okay? We're going to talk about mortgages. We're going to talk about saving for 50 years. We're going to talk about paying off your credit card once a week for the rest of your life. Like, you don't want to be typing in these numbers again and again and again. So we're going to use exponents. Exponents are repeated multiplication, as I'm sure you're aware at this point. So we're going to go. We're going to get our first formula. You will need to memorize this for your test. This is the formula for compound interest. Which I'm going to call the Payne formula. Done, of course, because math is so painful. Not even one table. Math is painful. So here's my equation. A equals, nobody? All right, that's fine. A equals P, 1 plus I to the n. Okay, so this is looking a lot like our equation we just started with there on the left-hand side. We're going to write P-A-I-N on the board sort of like this. P stands for principal, which is your starting amount. A is your ending amount. I is your interest per compounding period. And N is your time. All right. Yeah, we'll talk about all this stuff in a second. Okay, this is your first real equation, first new equation. If you came from 3M, you will know all of these equations when doing this unit and have a major advantage. For everyone else, so we'll talk these equations out loud. This is the simplest one. You think it's fair to say, Georgie, out of the three? Do you remember these from last year, I hope? Taylor? Rain is the next one. Okay, and rain is like this big, and PV is this big. Okay, so the auto method. All right, so here we go. Example 1, 2 we're going to do here right now. Let's start with Ben.
What does N stand for?
Well, it's the number of compounding periods. Fine. Okay. We'll talk with that. All right, let's start with Ben. Ben saves up, say, $10,000 for university. If he invests it at 8% for 4 years, how much will he have? Now this is a word problem. They were all going to be of this style. Okay, they'll be worded the same way. This is not like a weird question. This is a standard thing. Okay. I look for a certain when we're dealing with equations in this course, and there's going to be a few of them. I'm looking for a certain format to it. The format is first. I'm going to start with Ben. So you guys having a copy down. I'm too excited. I think I might actually take a stop here and